I told your instructor that I think you people are having a good time with her, so I just want to come and have a feel of your class, yeah? So let me put on
Yeah,
my
welcome, senior.
thank you. Let me put on my camera so that you all see me.
Oh, nice guy.
Oh, freshman.
All right, thank you. So I think I can put it off now. Yeah, so I am going to take your class for this afternoon session. Yeah, and I learned you are on programming, right? Is that right?
Yes,
That's right.
Yes,
Yeah.
that's right.
Yeah.
Okay, so introduction to programming, and you stopped at execution path, isn't it?
That's right.
All right, so I would get there quickly and I will share my screen, but kindly give me just a second, okay? And let me just sort this out.
No problem.
So I will share my screen and share. Please, can you all confirm if you can see my screen?
Yes, it's visible.
Yes.
Nice.
Yes, please.
Okay, so let's just begin. So I am much of a talker, so yes, you will have to talk. All right. Yes, I like to engage. I mean, when I engage, you also engage. We all get to enjoy the session together. Okay. So execution path. So what's the first thing that's, I mean, as a layperson, if you hear the word, let's do English a little bit, right? When you hear of execution path, what really comes into mind? What do you think? What do you really like get to think of when you hear of execution path before we even go into programming per se? All right. Yes, Dennis, go ahead.
Yeah, so execution part is the path of execution.
Yes, so in English we were taught that if you want to explain a word, you don't add the word itself because we want to understand what execution path is. So you don't mention execution, you don't mention path. Okay. So yes, I will appreciate if you come again. Yeah, so go ahead.
The execution part is sort of like the routine a program goes through in order to run or perform the task it's supposed to perform.
Awesome. Jesse, Sasu, Asante. Some of you, I'll butcher your names, but forgive me, yeah?
No problem. Okay, so with the execution path, it's a series of steps or process that the program runs to perform a specific task.
All right, that's good. Where are the ladies? Women in tech.
Please call Beatrice.
Beatrice.
Hello, Beatrice. Everybody says I should call you. Where's Beatrice? I can't see Beatrice here. Anyway.
Gifty too, Gifty.
Gifty is also there.
Hi, Gifty.
Oh, dear, hello.
Hi.
Sorry, I just joined the call.
Okay, so we are discussing. Oh, why are your hands down? Don't lower your hands, so I'll call you still. Yes, so we are. Yeah, so we are talking about execution path, right? In a layman's point of view. So when you hear executing parts, what comes into mind? That's basically what we are discussing. So I was calling for the women in tech, and they said, "Oh, Gifty is a strong woman in tech, so I should call you."
Okay.
Yeah.
So basically, it will mean the steps or the layout to follow
Sure.
to write a command or a program before it's executed. Yeah.
Right, great. Terry, go ahead. Hello, Terry. If you are talking, we are not hearing you because your mic is off.
Yeah, can you hear me now?
Yeah, I can hear you now.
So when you give a certain input, the sequence in which it comes out, basically in a binary format, is the execution part.
If we can speak big English, oh.
Yes, please. We studied it a lot.
Right. Ruben Jr., sorry, go ahead.
Yes, boss. I also understand it's an English formality that execution part is a working steps.
Right.
Yes, in short, a working step by which we can run a program. Thank you.
Great. You're welcome. So yes, these are all awesome submissions. These are great submissions by all of you. It is no different when we get into, when we talk about programming. Now, first thing, let me also iterate that the purpose or the goal of this is not to like train you or for you to become a programmer, but for you to understand what goes on, right, when a program is run, or basically what it means to program. Okay, that is the purpose of this module. All right, so it's just to introduce you into programming, some of the basic concept that goes into it. Okay, so let's look at the execution part. So as we all said, they are the logical steps that we give to a program. Yeah, the logical steps that we give to a program to run. So we say that, okay, I am writing a program that takes names and date of birth. All right. Now we say that we are taking, let's say, 10 names, all right, and 10 date of birth. So you can write a program and say that until the list or the number of names is equal to 10, the program should continue taking the names. And then when it gets to the last name, that is the 10th name, and then after the 10th input has been done, you should probably output number reached. So program exiting now. These are steps. So you are telling the program that until we have 10 inputs, don't close. So we are talking about the if statement, we are talking about the while statement, we are talking about the until statement, we are talking about the case statement, and then all that. All right. These are logical steps or logical flows that you give to a program. So the series of steps that a program goes through to achieve a result or a goal is what we call the execution path of a program. Does anyone has a question? Network.
Hello.
Yes.
Please
Gifty,
can
go
you hear
ahead.
me?
Yes, I can hear
So
you loud
it's
and clear.
the execution part. Is it sort of same as the algorithm?
No.
Or that
So
one is different?
no, so that is not an algorithm. So algorithm is the entire flow of your application, all right, from start to finish. Now, executing parts one way or the other is saying that, okay, you are performing this function, okay? So algorithm, let's take the same program that takes the name and then the age, all right, or the date of birth of users or of audiences or whoever we can call them. Okay, so the algorithm will be maybe the first step is to open the program. Maybe you click on start. The next is to what? Is to ask for inputs. All right, so if input is equal to string, then so the execution path forms part of the algorithm. All right. And then the algorithm is now the entire flow from the beginning to the logical stage and then to the end goal.
Okay. All right. Understood.
Yeah.
Thank you.
You're welcome. Okay, so we are going to look at, I think we have explained what an execution part is. So we are going to look at, yeah, Joseph, go ahead.
Okay, thank you. You made mention that execution path, it's a path that we define when programming. So I want to know if it's the programmer that defines the way it should be executed, or it is the structure of the program that already determines how it should run.
No, so it is you, the programmer. Obviously, the program in itself even doesn't exist. So you decide to develop the program, there is nothing like the program itself. All right. So whatever a program does, you, the programmer, defines it.
Okay.
Yeah. You're welcome. All right. So we are going to look at basically some common mechanisms that contribute to the execution part of programs. All right. So we are going to look at flow control that include loops, conditionals, and switches. These are basic things that forms for the execution part of a program. So loops, conditionals, and switches. So these are the three things that we are going to touch on a high level overview. All right. As I said, the purpose of this is for you to have an idea of how things work so that when you are using the Bolt app, you are using for your food ordering app, you are doing your ride hailing and all that, you get to understand what is going on so that this time when you type your phone passcode, all right, when you type your passcode for more than, let's say, 5 times, and then they tell you that, okay, you have exceeded the number of tries, so try again in 50 minutes, you get to understand what is going on behind the phone. These are backed by what? These flow control mechanisms, the loops, the conditionals, and then the switches. Are we good?
Yes.
Yes.
Yes, all right. We are good. That's fine. So let's move on. Yeah. So, I mean, we explained what execution part is. So at the end of the day, what you want the program to do is to what? Maybe it comes to an either or choice, comes to multiple choices, or perform work on each item in a loop. So you as a programmer should be able to what? Predict what those steps will do. So is it Joseph? That also answers your question. So for the flow or the execution part of a program, you as a programmer will have to define, all right? You have to define what the program is going to do. So the first thing are conditionals, okay? So let's look at conditionals. What does conditionals do? Or let's say we didn't see this, okay? For now, we don't know this, or we've not seen like what these things are. Okay, now let's look at conditionals in general. If I tell you that, okay, I'll give you money, let's even use the restart program. You know, you are to receive stipends, isn't it? But there is a condition, isn't it? The condition is that you get to do what? Your KCs, you get to do your code signals, you have attendance, you have participation. You have to meet all these requirements for you to qualify for the stipends, isn't it? So these are the conditions for you to get a stipend. So you being in the program or you just coming to class alone, isn't it? You have to participate. All right. You have to do quizzes. You have to do assignments that your instructors would give you. All right.
The lab.
Yes, the labs as well. Good. So these are conditionals, or these are conditions attached to whatever you are doing. So at the end of the day, if a simple conditional statement will say that if your labs, your cases, your everything are all checked, then do what? Give the person or the learner stipends plus data. Good. Else, you do what? No stipends. Okay, and then within that we can have other conditions, maybe else if attendance and participation is also checked but the other ones are not checked, okay, then just give the person data and then not stipends. All right, so you can have like nested if statement in a general if statement. Okay, so those are conditionals. All right, you do something till a condition is met, or when a condition is met, the program should do something. Okay, so this is an algorithm. This is not a program. This is like an algorithm for a conditional statement. Okay, now this program is to take a number. All right, so a number, probably a number have been passed. So let's look at a simple program here. Okay, I think I have VS Code opened. Okay, so let's define this algorithm. So this is just an we know an integrated development environment, right? If you don't know,
Yes.
Yes. Okay. If we don't know, we'll still talk about it. Okay. So this program, the program that we saw, all right. I don't like copying from the slides because it's going to appear in a one line. Let me see. So I'll copy this, paste it here. I said it. So I'm not going to use it. Okay. So let me just explain before I even go there. So basically there is a number that has been passed. There's a number that has been passed there. So let's see the number is, so this number, let's say it's equal to 10. Okay. The number is equal to 10. Now, what this program does is that it asks you to guess. Okay. Let me write my 10 where before they will say, this man doesn't know how to write 10. So it's a guess, a simple game or a simple program that allows what users to guess a number. So now if your guess is greater than the number, it should print what? Too high. Else, if the number is less than, if your guess is less than the number, then it should print what? Too low. And else, then it means this else is saying that if none of these conditions is met, then print what? Exactly right. So the number will either be greater than the guess, less than the guess, or what? Equal to the guess. Yes, equal to the guess. And then we have what? Exactly right. So this series of conditions is what the program will go through to arrive at an answer. So when you get too high, then it means the condition of what? The guess being greater than the number is met. Okay. And then if you are seeing too low, then it means the condition of what? Your guess being less than the number has been met. And then if you are seeing the exactly right, then it means what? You guess the exact number. All right. So this is one type of what? A flow control or a flow mechanism. That programs what goes through. Now let's look at your phone and then your passcode. Okay. So passcode for iPhone users, and then is it PIN or for Android users? Okay. Now you realize that at a point when you type your passcode for, let's say, more than 3 times, it's make you pause. So it will tell you to try again in what? In the next 15 seconds, isn't it? Now, after 15 seconds, if you try again, and then you type it more than 3 times, and then maybe you exceed it, it will tell you to wait for 30 seconds. I think after 30 seconds, you are logged out of your phone, because there is a logical statement that has been what? Put behind that program that takes your passcode. All right, there is a logical flow that is stating that, okay, first you will set your passcode. So let's say you set your passcode as what? Restart. Right, immediately you set your passcode for the first time. Now the program that takes your passcode will say that if let's say user input, so it will say if input is equal to what? Restart. Let me use VS Code for that. This caricature drawing and effort. All right. So your passcode program will basically say that if input is equal to what? Restart. Yeah. Then maybe to say then, let's say allow
Pass out.
allow login. Okay. Else, if input is equal to no, so this one will just be else. So else, all right. Lock. Let me use lockdown. Okay, maybe off an answer. Okay. So this is basically a simple program. All right, that will take your input. So if your input is equal to restart, then it should allow you to what? To log in. Else, if your input is anything different apart from restart, then it should lock you down off the phone. Okay, so that is one of what's the logical, or the logical flows or the flow control mechanisms for execution part of an application. Okay, so basically the program that you have been using, the application you have been using on your phone is just a series of what? Conditional statement or a series of what? Flow mechanism. Any question? Yes, Yabet, go ahead.
Okay, so I'm just looking at this logic app here, where we are having to guess a number. Okay, so if the guess actually happens to be equal to the number that we have kept out at the first instance, is it going to jump straight to the last else and say exactly right? Because
yes, it will print exactly right.
Which means that the first if wouldn't be considered in.
Yes, because the condition is not met here. So when you enter the number, all right, let me just, because this thing comes in one line, that is why I don't like it. But let me just put it here so that we'll even look at it into details, right? I'll go through the pain, and then so this and this, we got it right. Yeah, and delete this. So if yes, exactly. All right, so go ahead. So basically a correct program will just have this. So let's say number is equal to 10. So because you have to define that variable, okay? You have to define the variable like this, sorry. So 10 like this. So if we have the program like this, okay? So, okay, Jesse, go ahead. Jesse, your mic is muted.
Sorry. Yeah. I think I wanted to add something, but so I was going to say that you see when you hit, let's say in a debug mode, when you hit, it will come to the first condition. Once it does not meet, it will move to the next condition. Once it does not meet, it go to the last. If it meets, then it will print the last one.
Yeah. So yes, that's basically what a program does. All right. So for a program to finally give you it's a guess program. Okay. Yeah, so for the first, so I pass a variable. So this one, have you talked about variables yet?
Yeah, we have, but we
Yes,
have
please, yeah.
demonstrated.
Okay, so yes, so this is basically how you pass a variable. Okay, so the variable and then the value, isn't it? So now I've passed the value 10 to this variable called number. This could have been anything, right? It could have been anything. So I could say my number, but it means it has to what? Be the same as here. All right. So I pass this variable here because my game is taking the guess of what? Users. All right, the guess from users. And then I will now take, so in Python, we will treat Python shortly. So let me use Python, okay? So in Python, I will say, so guess, okay, is equal to what? Input, all right? And I think I'll put it into, so I'll make it an integer. I've forgotten the whole thing, but so an integer of an input. Good. So it means I'm converting this into what? An integer. When we get to Python, we get to know this. So here it will take an input. Okay. So the guess will be a user input, isn't it? So what it means is that when you run the program will ask you to guess a number. Yeah, Yakubu, go ahead.
Okay, like yeah, like I was about to ask, like, how will the computer know the guess number?
Yes, so you need to first pass a variable first. All right. So when you input your number, okay, now this time it will take the variables. Okay, so maybe the user is going to input 10. Okay, the user is let's say the user inputs 5. Now when you input 5, the program itself will now go through to execute, okay, to check. So is the guess number greater than 0? Greater than the number, which is 10. If it is not, it will just move to the next condition. All right. Is it less than the number? Then if it is true, and that will be true. So here the statement will be true, then it will print what? Too low. All right. But if the user, let's say, input 10, it will come and start from here again. Is it greater than the number? No. So it goes to the next condition. Is it less than the number? That's no. And then it goes to the last condition. That is what? Which is true, because if it is not greater and it's not less than, then it is obviously equal to what? The number. All right, so it will print what? Exactly right. So the program is to not print a statement per check. All right, it checks it per the condition, because this is one program. All right, so it has to go through all the conditions. The one that favors the guess is what is going to output the result. Please, is that okay?
Yes.
All right. Any question? Okay. So when you book a ride, either Bolt or Uber or what have you, you can see on the app it will say searching for what? Searching for driver, isn't it? Searching for an available ride. So what's basically is going on the program? And on the driver's app, the drivers will have to what? Also change their status to either, I think, online or available or so. So what the app is basically doing is that it is going through a series of drivers' names to see the ones that are available. Okay, so it will loop or iterate through all the available, drivers. And then when one of the drivers accepts the ride, before it will even come and tell you that, oh, found a driver, and then maybe a driver will get to you in 5 minutes or what have you. All right. So it is checking on what? A condition that a driver status is available. And then for it to assign you a driver, or the driver at the other end will have to accept the ride before. All right. So that is just a condition. So all the programs that we've been using are running behind a series of conditional statements. So this is a Python example. Okay. So this typically the stipend example that I gave you. All right. So here they are using names, all right, to assign to increase, kindly give me a moment. Yeah, sorry for that. Okay. So here they are using what? A name. So if the person's name is Juan, all right, we can say Juan, okay? If the user's name is Juan, then the bonus is what? Is equal to 300. But if else, so if it is any other name aside Juan or Juan, then the bonus is what? I think it's just 1% increment, 1% of what? Their salary. So unless your name is Juan, then you receive outright bonus of what? 300. But if you have any other name, then your salary, your bonus is what? Your 1% of your salary. Is it 1% or 10% of your salary? Yeah, Musa, go ahead.
Yeah, Isaac, thank you. This looks like just one condition, just one or two conditions. What happens when we have about 6, 7 conditions to be met?
So that is where this one comes in. All right. So as I said, you can have what we call nested if statement in what? One if statement. So here, if there were like several conditions, okay, you can do else if, else if, else if, else if, till you get to your last, like your final conditions. Okay. There is more effective way. You can do until. There are other advanced ones, but as I said, this is just an introductory stuff, so we might not go into all those advanced, programming concepts. We have do until, we have for the four loops. Okay, so for this is equal to this, do this. Like there are a lot of if statement or conditional statement to include in your program. Okay, but this is just an introductory stuff, so we might not cover extensively into all the programming concept. This is just to give you a high level overview or an idea of how programs are created. Is that okay?
That's fine, thank you.
You're welcome. Yes, and I think you did bash, isn't it? Bash scripting. Yes, so bash scripting, there's like you did elif. The name, we call it else if, but it is spelled elif, right? So here, let me just do this. So this one comes this way. This one comes back here. And this, nice, okay. All right. So here, if I can also say, so before the else, okay, I can say elif, nice. And I say, so name is equal to what? Musa, all right. And I'll say bonus should be equal to 1,000. All right. So if I have another condition, I'll just put elif like that. So it's continuous elif, 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 and then so your final one, then you say else. So if the conditions, any of these conditions are not met, then the person's bonus should be what? Just is it 10%, right? 10% of their 10% of their salary. Okay. I'm the last person you would trust with mathematics. All right.
I am programmer.
Yeah, Calvin, go ahead.
Yeah, okay. So with the if name equal to sign, why is there equal to sign?
Good. That's a good question, a good observation. So when you are dealing with strings, most of the times you use this, okay? When you are dealing with like strings, but when you are dealing with integers or numbers, then you use what? One equal sign. So as you can see, this one, okay? Yes, Dennis Nana Seche Oche. I like your name. Go ahead.
Yeah, so I wanted to contribute more on the equal to sign. So
Nice. Go ahead.
when you use one equal to, you are assigning a value to a variable.
Right.
But when you use double equal to, it means you are comparing. So here in this case, bonus equal to 300. We are assigning 300 to be stored in bonus.
Bonus.
Variable.
More.
But name equals Musa. We are comparing the whatever is stored inside the variable
name to
whether it is Musa. So you are comparing that, okay, is Musa stored in name? But here in this case, we haven't specified name, so we can't tell.
Nice.
The user specifies what should be in name, then we can compare whether it is Musa or one or whatever. Yeah.
Super.
Yeah,
Dennis.
thank you.
Yeah, Ruben Jr. Asari.
Yes, I also add a little to my brother. I think it's a technical thing that's, it's a computer language. So in terms of program, there are certain things that whether you like it or you have to take it just like that. It's
Like
like a
that. I like
So
that.
sometimes you may ask why these two equal signs. That is the formula for in programming, per se, a pattern. So I think my brother, there are certain things, it's a formula that is like mathematics. It's a formula. You cannot do anything about it. Thank you.
Okay, you're welcome. All right. But it's also good that you get to understand, okay, I mean, basically what is happening behind the hood. So some of them, if you're able to find understanding, you move with it. If you are not, you decide to move on or you keep searching. Okay. Just as somebody, I think in one of my classes, somebody was asking, why am I using? So I was using VS Code for my test editing, and then after some time I switched to Notepad, and the person was asking, why am I using Notepad like now? They were thinking that maybe it gives me an extra, I mean, it's just a different thing. I was like, no, it was just my choice, like this time or that time. I was even expecting you people to ask me, why am I using this one? But thank God nobody asked. Okay. But it's basically a text because, IDE gives me the environment to do everything. If I want to use a terminal, I can use it. If I want to do text editing, I can, use it. I mean, my VS Code is even able to view PDFs and then pictures and then all that. So I like to use it every day. It's on. Good. Let's move on. So we are good with the if statement, right?
Yes, please.
Good. And then we have switches. Okay. We have what? We have switches. So let me use how many of you drive here? I want to use a car as an example. Okay, Dennis, since you drive, do you have an idea of, I mean, maybe a high level idea of what a switch is? Oh, Eric, I will not ask you. You are putting your hands down. I know. If you have an idea, just go ahead.
Okay. Maybe switching lanes from an outer lane to an inner lane.
Good. Just anyhow you.
Okay, so that's what I can relate with driving.
Good. That is the exact thing that I was about to say. So switching in programming, right, is we call it a selection control mechanism. That's one way or the other changes the flow of a program, okay, based on what? A condition or based on a value or an expression or whatever it is. Okay, so as you can see here, they still related this to a vehicle. Okay, but I am not going to use this case. I'm going to use in a lane. So those of you who drive in Accra, you know what goes on when there is like a lot of traffic. The driver can stay in one lane, look at the lane and see like, no, the outer lane is moving than the inner lane. Then they move to the inner lane. So here, in the driver's mind, the conditional statement that he has, programmed, or the switch case that he has programmed in his mind is what? If lane, one lane is moving than the other, then I should what? Switch to the other lane. And that is the same thing. That is the same conditions they use to, program self-driving cars. All right. These are the conditions that are used in what? Programming self-driving cars. Okay. Kindly give me a moment. A lot of things are going on here. Right. Okay. So the self-driving cars have these conditions. They have these switch cases. Okay. So if you want to accelerate, what do? You press the acceleration or you step on the acceleration pad. Okay. If you want to stop, okay, what do? You step on the brake. So in vehicles, you can find these things there. Okay, these are just it. So in programming, you will say that, okay, the same thing with your, let me go back to the phone and then the passcode thing. So, okay, you have had 3 tries. You waited for 15 seconds. And then you do it again. 3 tries, you didn't get it. You waited for 30 seconds. 3 tries, they wait for what? 60 seconds. So you can have a case statement that says that if retries is greater than, let's say, 6, okay, then switch to what? Lockdown mode. So in lockdown mode, it will require you for what? A different credentials altogether. Maybe your iCloud or maybe your Google account for Android phones and then all those things. Okay, so this is what, like switching from a mood or switching from one flow to the other. Okay, there are you see, there are some applications that when you enter your logins, let me take a popular shop for example. So there is a shop that has this application that works in a way that when you are buying items for, let's say you buy items that are, greater than a certain number, you buy like quantities greater than, let's say 5, then you are charged what? A wholesale price. So the wholesale calculation is different from the retail calculation. Okay. Yeah, Jesse, go ahead. Jesse, Sasu, go ahead.
Okay, so I wanted to come up with a scenario quite different from the car.
Okay, go ahead.
We're looking at USSD code. So
yeah, USSDs, yeah.
Just want to use your mobile money, and then it takes say a value. Then for the value you enter, it will switch to say a particular options, and then guide you through till you are able to withdraw money. So it's also follows the same point.
Good. So that is basically how switch cases work. And then there is even, the USSD codes, there is a wait time, isn't it? I think is it 1 minute or 3 minutes or so? It's also after a wait time. After a wait time, it just exits the application and then tells you the MMM code or is it something code is invalid. So these are switch cases. So in the USSD, there's menu 1, item 1, item 2, item 3. So based on the number that you select, it will open a certain dashboard for you to continue your transactions. Okay, so those are switch cases. Any question? We are moving like that too. Oh, you mean Akosia is still here? All right. So let's look at loops. Okay. So with loops, you pass certain values or a variable, the same thing, and then you say that, okay, so for name in names, okay, for name in names, Osman, yeah, go ahead.
So please, I just wanted to ask, so the switch and the nested, if which one is more efficient to use?
It depends on you, the programmer, your use cases. Okay, there are programmers that Yes, Beatrice is here. I learned Beatrice is the senior woman in tech. Hi, Beatrice.
Yeah, she's a wizard. Wizard of Oz.
Hi, Beatrice.
Hello.
Yeah, I'm struggling to hear you, right? So so let's help Mr. Yaya here. So Yaya is asking, so for the switches and then the if statement, which one is effective?
Okay, so we usually use if statements for when it's either like you have like 2 or 3 cases. So you can have an if else, if and then else.
Right.
But if you have more than 4 or 5 cases, so let's say you are in a company and there are like 7 branches and you have to make a condition to fit all these branches, it will be ideal for you to use a switch case scenario.
The ball.
Thank you.
You're welcome. All right. So it always depends on what. So in the even in cloud, right? We are learning to be cloud engineers, right? Even in cloud, the most popular statements that you will hear is that it always depends on what your use case. Please, are we okay?
Yes, please.
Right.
Yes.
So it always depends on what your use case. So here for loops, let's say this program is basically printing what the capitalized version of these. So we are saying that for each name in the list of what names, the new name is what capitalized name. So print new name. So this will print what Way in caps, Nikki in caps, and then Ekua in caps. Please, are we okay? Or I should go over again?
Yes, please come again.
All right. That's fine. So for loops, all right, for loops, we are basically iterating against what? A collection. Okay, we are iterating against what? A collection of items or values. So here we have Way, we have Nikki, we have Equia. So this, the variable is what? It's names.
It's names.
All right, this is a variable. So we are saying that for each, this one, for name in names, we are saying that for each item in this list, please capitalize the name. Okay, so now we'll print the new name. So what this program is going to do is that it's going to what? Capitalize these ones. So it will print the new name, okay, to print the new name. So that is Way in caps, Nikki in caps, and then Ekua in caps. And then the program will exit. This is clear.
Yes,
so
please.
It means that if we have 10 items here, it will iterate against all the items, print all the 10 items, and then now it will what? It will exit.
Exit.
All right. So that is for loops. So loops is basically going back, checking the item, doing what it's supposed to do. Then it will go back, check the item like that. So let's take me. I come from the typical coast. So how many of you have seen people offloading cement from a truck, or like offloading any load from a truck? So you get to realize that till whatever is in a truck is finished, they will have to go back, pick it, come and drop it at where they are supposed to drop it, go back, pick it, come and drop, like that. So this is basically what the program will also do. So they will be in a loop till every item in the truck is what? is catered for or has been what offloaded. Ruben Jr., sorry, go ahead.
Yes, what makes the output to be new names? Because already the names are
It's
already
offloaded.
yeah, the name is already there. So when you print it out to be at the output, what makes it a new name?
Nice. So as you can see here, the names are already here, isn't it?
Yes.
Now we are just passing, and then here we introduce a new variable called name. All right.
Okay. Yeah.
This stands for each element in the variable names. Okay. We introduce a new variable here that for this one in this list. Okay. So this stands for what? Each item in this list. And then we are saying that the new name, so we have introduced another variable here. Okay. The new name will now be equal to a capitalized version of what? Each item. That is what the new variable we introduce here, name.
Okay.
So if we are printing the new name, then we are printing a capitalized version of what? These individual items.
Okay. That means it's stressing on the name.
Exactly. Yes.
So is it going to be also capitalized or into strange or
no? So it will print each item like Way, Nikki, Equia, like that. Musa, go ahead.
I get it. Thank you.
You are welcome, boss.
Yeah, my question is is it names because there are names in the variable?
No. As for variables, you choose any name you would want to give your variable. All right. Okay. As for variables, you can put anything. So even the new name, you can just say name in caps or something. Like it's a variable. So you have to, there are just standards that you need to follow when you are naming your variables. And I think that one you've already looked at that. Yeah. But you can choose any name that you want for your variable. Okay, so this is an example from Python. So here, so just like the one at the top here for the salary thing, okay? So this is what has been written in the for loop. So in this for loop, they are just, in this for loop, we are just doing what? I mean, giving a bonus of what? 10% of what? Every employee salary. So now we are not even exempting if you want one from getting 300 or something. Okay, we are not restricting it to one. So for each employee in the list, so we have to, so for this first you have to define the employee's variable with what the list of what the employee names or whatever it is. If it is the ID you would want to use, you have to put that list. And then here we are saying that, okay, so the employee dot bonus, right, this is another variable. So employee bonus is equal to what? The employee salary times what? The 10% of their salary. So their bonus is just 10% of their salary. Okay. So instead of writing that thing in what's it called? That format, we are now using for loops for this. So this one is going to what? I'll give a bonus of what? 10% of each employee salary. And this our salary 100 cedis. You know your bonus. Okay. So I mean, any question before we get into version control? Here we are going out of the programming thing. We're going into version control. So I mean, let me take your questions. It's 3-7. I think we can spare 3 minutes for questions, and then we start version control on exactly 3:10. Any question? Can we move on? All right. Or you are thinking about your questions?
I think we are good for now, please.
All right. So let's move on to version control. When we say version control, please, let's move away from tech. All right, let's do English first. Okay, let's do English first. When you hear of version control, what comes into your mind? So for a layman, you see somebody, what do you think version control is? How will you explain to the layman without even being programmatic or sounding like a tech person? Yes, Mr. Terry Akoto, go ahead.
So it's just you are tracking and then managing changes to codes.
Let us not say code.
To your commands, something commands.
Don't mind me. That's okay. All right. Anybody else? All right. So just as is it Terry? Is it Terry who just spoke?
D'accord.
Yeah. So just as Terry said, right? So version control is basically you tracking changes, okay? Changes to your resources, all right? Or in programming to your code. So you have a team of programmers who are working on the same product. I see. All right. So you have a team of programmers. You have Beatrice in there. Who did I call first? I think Gifty, right? You have Gifty in there. You have Terry in there. You have Dennis in there. And we are all working on the same program. So obviously, the application code is the same thing. Okay. Dennis will come and do some changes. Beatrice will come and effect some changes. Gifty will come and effect some changes. Bruce will come and effect some changes. All right. But at the end of the day, we would want to also keep multiple versions of the application. So you know how WhatsApp started, isn't it? You know how WhatsApp started, how the interface was. And then there was an update, maybe version 2. There was version 2.1. There was version 2.2. And then we go to version 3, like that. And then now the interface of WhatsApp is not even beautiful again. All right. Now, so let's say the intro.
You say again.
Don't worry, I have more things to say. Okay. So these changes, so let's say they do a change. Yeah. They do a change and the current change crashes. It goes down. It is not working. It is not even achieving what it is supposed to achieve. How do we go back to the old version? I know, how do we quickly roll back? If you're not keeping versions of your application, right? If you are not versioning your application, you get to lose control of your whole thing. So you mean that you have to sit down and then rewrite everything again. Okay, so Emmanuel Awuku is asking that can we liken what happens inside, say, our word processing software as a form of version control? So there is an undo and redo button that we can use to either go back or return to the earlier change done. Exactly. So that is just like a version control feature in Microsoft Word. So every changes that you do, all right, it saves it. You delete a text, it saves that. You add a text, it saves that. You change the page color, it saves that. You change the text color, you change that. So you realize that, okay, you've changed your text to red. Don't say no, red with the and fat. All right. Once a red with the and fat, what do? You just press the undo button, you go back to the previous changes. So exactly that is how, what goes on in what programming. You can have multiple people working on one program at the same time. But each version, so version 1 has a version there, version 2 has it there. So immediately you roll out a new version and then you realize that it's causing problem. You quickly roll back to the previous version whilst you work on the current version that you just rolled out to fix any bugs or any problems with the code. Please, is that okay? So that is basically what version control means. Keeping track of smaller changes. And even with version control, we're able to also track who made what change. All right. Okay, so I've basically explained the need for version control. We are going to look at Git, and then we'll look at the difference between Git and GitHub. Okay, I might be tempted to, so let me just go into the thing. All right. So I've basically explained version control. So it's a software that tracks versions of your code and then documents as you update them. Okay, I've explained that. You can also do version control locally on your computer or by using a website that is dedicated to saving these versions. And then one of the websites that we are going to look at is GitHub. Okay. And with version control, you are able to, or it encourages collaboration. Okay, it encourages collaboration, where multiple people can work on a single project, and you are able to even track the changes that each person does. Okay, and you are also able to roll back to a previous version whenever the needed be. All right, any question on version control in general before we move on? All right, so let's move on. So the advantages that it comes with: ease of access, you're able to track errors, and then it's also, safe in terms of security. Okay. Now, we just saw that we are able to do version control locally on our local machine. Okay, but that wouldn't be effective, because if you are doing version control locally on your local machine, it still stays in your local machine. You are the only person that is able to track it. Now, a popular way of graphic, anybody who's a graphic designer here, or anybody that has had a graphic design background here? Okay, Dennis. So yeah. Okay, Euku has been doing graphic design before. Great. So, graphic designers have a funny way of saving their files, all right? You see client 1, flyer. That is the first one. Client will request a change, they will do it. Client 1, flyer 2. Okay. Client 1, flyer 3. And then they will now come to client 1, flyer final. Client 1, final 2. Client 1, final. All right. By the time they finish the final design, they've had like final.
Client 2 101.
you get it. So that is their own their way of version control. They would want to keep multiple versions of the changes that they are doing, so that, because there are some clients that yeah, there are some clients that they will do all the changes and then still finally take you back to the first ever design that you did. So imagine you just overwrite. Imagine you just overwrite the first one that they tell you to change, and then you just save it on the first design. That is not an effective way. It means that if finally the client decided, okay, let's go back to the first ever design, then it means you have to even sit down to redesign the whole work again. Okay. So that is basically it. Okay. So if you are doing, and then that one, if you are doing your version control on your local machine, what happens? It means that it only stays in your local machine. So when that is lost, it is gone forever. So that is important. It is important that you get to use a cloud infrastructure. Now we are training to become cloud practitioners and then cloud engineers. Okay, so we have to marry cloud, or encourage using cloud. So what cloud version do we use for our version control? This takes us to Git and GitHub. Okay, there are other version control tools, right? There is Mercurial, there is GNU Arc. Okay, there's Mercurial, and then there's GNU ARC, and then there's Git and GitHub. That is what the most popular version control tool that we can find. Yes, and there's Bitbucket too. Good, Jesse, thank you. There's also Bitbucket. Okay, there's actually like several, I mean, Git version control tools, okay, but very few are mentioned in this slide. You can just do a simple Google version control tools and it will have plenty things. Version control tools, okay. See, these are all some of them. There's even GNU Bazaar, there's Code Commit. Yes, you will learn about Code Commit, okay. You will learn about Code Commit when you go to AWS, when you are doing like the AWS services. All right, there is Helix Core, Apache Subversion, there is Bitbucket, there is Plastic, SCM, a lot. Yeah, there's a lot of them. Okay, that you can look at, but I mean, there's no need memorizing version control tools. If you don't get a GitHub, you don't GitLab, you don't Bitbucket, you are good to go. Okay. I'm one of the laziest cloud engineers and then tech people you can find. I don't worry myself about things that I don't need. Okay, so this is Git. All right, basically what you do, you first have to install the Git tools. You can add files to a repository, you can edit files in a Git repository, you can clone an existing repository, create and then merge branches, rewrite history in Git repository, and then resolve merge conflicts. All right, these are the things that you can do in Git. Now let me tell you about the difference between Git and then GitHub. Emmanuel, your mic is on. You want to say something? Okay, all right. So GitHub is the cloud, okay, storage, please. Let me not do this. It's not good. Isaac, repent. Okay. So Git, GitHub, okay, is what? The cloud storage. Let me just put it that way. Okay, the infrastructure that stores what? Your code for your code. Okay, for your code. Yeah, and then Git is the CLI tool, right? The command line tool. So let me put terminal clear. So what is going to let me type like Git commands is what we call Git, the tool that allows me. So just like, have you learned about anything AWS, the AWS CLI or anything of that sort? Your first week? I'm sure you spoke about it, right? So the tool that allows you to enter AWS command. So for you to do AWS IAM, okay, list users is what? Because of, okay, I don't have AWS CLI installed on this line, or this is a virtual machine. That is fine. Okay. But the tool that will allow me to enter AWS commands is what? The AWS CLI. So the tool that will allow me to enter Git commands on my terminal is called what? Git. And then the GitHub is just what? The storage. Okay. The repository that stores, the cloud storage that stores your code. Okay. So I will see if we have some time. Those of you who don't have GitHub accounts, anybody that doesn't have GitHub account or haven't even used GitHub before, I'll see if you have some extra time. I'll just take you to a simple hands-on on how to create your account, create a repository, clone your repository to your local machine, and then push it back. All right. I like hands-on. All right. So these are the actions that you basically do with Git. Okay. Any question? Emmanuel Odum, somebody is calling you. This name seems familiar. Hello, Emmanuel.
Yeah. Hello, Isaac.
Yeah, it looks like I know you from somewhere.
Sure.
Ah.
Joe Max.
Oh, okay.
All right. I'm around.
Yeah.
I'm following.
Okay.
Thank you.
You're welcome, boss. All right. So I think these are just the steps to install Git. Okay. So, so let me just take you through a short. Those of you on Windows machine, okay. If you are using Windows, please don't ask me why have I changed the terminal. I just want to have multiple terminals. So I'm logged in on a Linux operating system on this. Okay. So I am just exiting this. This one is my local machine. Exit. Okay. So this is my local machine. And then I have a Linux operating system installed here. So those of you using Linux, okay, operating system, the Ubuntu's and then what have you, you can just use the apt install Git, okay, and then Git will be installed. So as you can see, I think I have Git already. So let me see, Git minus version. Okay, so as you can see, I have what? Git installed. Okay, now if you're on Windows, you can just use a utility called Chocolate. Okay, so you have to install Chocolate first.
What?
Chocolate. This is the name. Let me open here. So there is a tool called Chocolate. Okay. Yes, so there's a tool called Chocolate. If you want to install Chocolate, you can just do Chocolate latte install Windows. Okay, and then it is okay. So if you do installing Chocolate, the steps are there. So what you need is your PowerShell. All right, open PowerShell. So you search for PowerShell as an administrator, like this. Okay, it is going to open a terminal. That's Windows native terminal. Yeah.
Linux net market for now. What
Yeah, so I started from Linux, right? I started from Linux and Ubuntu, and I'm on Windows. So obviously I'll get to Mac. How we train Anna. Okay. So you just run the command, copy this command, paste, and then run it. Okay. And then I think you should be good installing Chocolate for the first time. Yes. Okay. So you just run this command and then you should be okay. So that is it. So after you install, if you want to install anything, after you install Chocolate, you just do Choco, just like you use apt or apt-get. Okay, Choco install, and then I'll say get. Okay, I'll add the -y to automatically say yes, but I already have get installed. Okay, so you see, yes, I'm not running it as an administrator. So yeah, that's what it's saying. So it might feel so you have to always run it as an administrator. Just like if you are installing on Linux machine, you have to add what? Sudo. Okay. For Mac users, you only have to do brew. That is if you have brew installed. So if you don't have brew installed, you have to install brew. Okay. So you do brew, install, and then the application name. So this is what Git. So when you install Git, then you are able to type Git commands or use Git commands. Okay, yes, Chocolate is sweet. All right, but Windows native installer, all right, package installer is winget. This one, winget. Okay, so you can also do winget install Git. Let me see if winget has a package. Yes, so download and install Git with winget. So if you click on this, yeah, so you can also do winget. So the reason why I don't like winget is the fact that you have to add the ID. Okay, you have to do e.id and then git.git. Okay, when I can just type something install git. So if you should do this also on your Windows terminal, you should be able to what? Install git on your Windows machine. Okay, so that's basically about that. So that's the procedure to install Git on your PC. Okay, so after you install, we can now create a folder. You did Linux, isn't it? So how to create a folder? You do what? Your make directory, git test, you change the directory to that. You can just put in something. So if you want to initialize it with git, you can just do git init. Okay, when you do git init, it will initialize git. So git will start what? Tracking that directory. All right, so this, I think we can try it on our own. I want us to cover Python today as well. So if I have free time, we just go through that. All right, but you first have to have a GitHub account anyway. Okay, so you just have to go to GitHub so that you can push it. You can push your code to GitHub. So this is GitHub. If you want to sign up, you can just type your email address here and then you click on sign up. Okay, it's just a simple steps to follow. All right. Then you have a GitHub account. So when you get a GitHub account, let me open my GitHub account here so that I'll show it to you. Good. You are going to have a homepage like this. Maybe yours might not be like this. Okay, yours might not be like this because you might not even have a repo or anything. So if you want to create a repository, you will see your name will be here like this, and then you see your repository name. So when you click on this, okay, I can create. So let's say restart repo. Okay, so this is a repo. I've created it. I'm making it public. I can add a README file, and then I'll just create a repository. Okay, so once this is created, if I want to now work in this repo on my local machine, I can just come to code. You can use SSH or you can use what, HTTPS. When you are using SSH, just like you do SSH into EC2 instances, you need access keys. So I will have to, thank you, Richmond. I will have to create public keys, right? So that I can use what the SSH. But Soft Life Gang, I will use HTTPS, okay? So I'll just copy this URL and on my machine, okay, it didn't install. I don't care because I already have Git installed. So let me do CD. This, I'll do CD, document, press enter. Okay, so I'll just type git clone. Okay, and then I'll paste the URL of my Git repo and I press enter. Okay, so you can see it is cloning what into that repo. All right. So if I do CD restart repo, you can see the repo is there. All right. Now let me just create a file. Okay, no, let me create a directory. So mkdir, because I don't know if touch will work on Windows. All right. So I'll do mkdir and I will say new folder. Press enter. Okay, so I've created this file in the restart repo. So first, let's verify something. All right, so here you can see I have only what the README file here, isn't it? So let me just resize this and put this thing here. Good. Okay, and then now I will have to stage the new folder that I created. So I'll just do git and I'll say git add, okay, and then that's the current directory. So if I press enter, now it has started tracking this file. All right, so if I do git status, the working tree is clean. Okay, the folder has nothing in it. Okay, so let me add the folder. Will touch work? ls Let me do touch some file.txt. It worked though. Oh, nice. So let me now do git. Let me clear the screen. Say the thing has gone down. Yes, let me bring it up. So I'll do git add. Let me do git status. Okay, so as you can see, I have two changes to commit, right? So I have a change to commit. This is the file.txt. Okay, so now I can do git commit. You have to add the message. So -m for the message, and then I'll say test file. Press enter. Okay, and then I'll now do git push. Nice. So the file has been pushed to my what? My GitHub repo. Now, if I should refresh this, I should have a file in here. So you can see the file that we created has been what? Committed. And you can see the commit message that comes with it. So let's say another person writes a file. Okay, this same file, they edit the file. All right, and then maybe put some text in there and commit it. It will come with its own commit message. So if I say that, okay, I don't want this file to have a text in it, and then I wouldn't want to just create a new file and a new empty file and then push it. All I would just do is what? I'll revert the commit statement. I'll revert the last commit, and then I will go to what? The previous commit that was committed. So that is version control. So here, anybody at all can, collaborate on it. And you can even go, copy other people's repository, other people's code. Okay. And then also edit them. There are some, if you look at my homepage, Akosia has even, there is a word that I'm not comfortable mentioning, a gate word that I'm not comfortable mentioning. So I will not say it. There is this word. Let me go to my profile. Yeah, that's what Beatrice has typed in the chats. Yes, that's the name. I want a repo that I can do that. Okay, I want to show you. Aha, you see, this is it. So if you want to copy somebody's repo and then make it your own or put it in your repo, you can use this option. Okay, you click on it and then it will just copy.
I can't see it well. I mention it there. I can't see it well. Please mention the word.
Let me zoom in so that you can see. This is it. Okay.
Oh, d'accord.
Yeah. So you are able to copy it and then keep it in your repo as well. Okay. So that is basically about Git. So I'm sure going forward, your instructor will give you an assignment. She will tell you to write script, save it in your GitHub repo, and then send her a link. Okay, send her a link, and she will inspect it. I did same for my learners. They created bash scripts. Okay, and then even for Python. For Python, the first 10 Python exercises, you will have to do it and then save the files, each of the files in your repos, and then send it to him. It's a good exercise. I did some when I was in ALX. Let me show you. ALX low level programming C. Let me see if they are here. So as you can see, so I create a folder in the repo, and then these are files. These are just bash scripts that we created 2 years ago. So as you can see, so this folder has what? All this. Okay, and then if you come here, we call it directory. Okay, so almost all the low-level programming assignments. Unfortunately, I couldn't continue because I traveled. So yeah, I couldn't continue. Yeah, but I did everything till after probation, where we're going into stuff. So I have all of them here. So you'll be doing something like this, but you are not going to do low-level programming anyway. You are going to do shell script and then Python scripts. All right, so that's basically, so here it's here forever till Git goes down or till GitHub goes down. It's here. So as you can see, it's 2 years ago. So they are all here till GitHub goes down. If I had it on my local machine, I've changed my machine for about 3 times or so. Right? If I have it on my local machine, I'm sure by now I would have lost it. Okay, so that is the beauty of version control. No, but ALX is nice for me. If not because of work, like I would have still continued. The time I decided to continue, and there came cloud. My long searched girlfriend, cloud. So I just said, okay, then. Let me do my cloud. And I'm enjoying cloud so far. Okay. Yeah, so this is a continuation of the whole Git thing that I did 13 steps. I did it in about 4 steps or so. All right. So how to commit? So you have to do a Git. So how to configure? I was expecting someone to ask me this question. So the reason why I'm able to do this, all right, to my repo is because of what I have configured the command line, just like you do with AWS. All right, I've configured my command line with what my Git credentials. Okay, so for you to do that, just like AWS, you do Git AWS configure. With Git, you do Git config global user.email, and then you put your email address that you use to register your Git account. Okay, and you do Git config global user.name, and then you put your name there. All right, as well. Then you have fully configured Git with what your GitHub credentials. Then you can do the cloning, the pushing, and everything into your GitHub repo. All right. Please, any question? Yes, Betty. I remember Betty. You can write your code very nicely, and Betty will say, "Oh, nah, it's not nice. You have to do it again." All right. Please, any question on Git? Yeah, Emmanuel, go ahead. Your mic is muted, Emmanuel. Emmanuel, your hand is up, but okay, Emmanuel Auku. Sorry, are you the class that have plenty Emmanuels?
Yes, so plenty.
That is why everybody was quiet. Okay, Emmanuel Auku. Go ahead.
I missed that. What did you say? The network broke. What did you say?
No, I was asking, are you the class that have the plenty Emmanuels?
Yeah, I think we are.
Yeah. So you had your hand up.
But maybe I will take you, but I just wanted to know that, yeah. So let's say that there is a condition, maybe like, let's say age or something. And
okay,
the first block of statement, then there is an if, right? It meets that condition. Then there's another
Auku's network is...
statement like an elevation. So what would happen?
You broke midway. Ask your question again.
So I was asking that for a conditional statement, right? If there are chains, that is like you have an if, an elif, another elif, right? And then the first if is met, the elif is also met. What would be printed? Is it just the first if or both of the if and then the elif?
Okay, give us an example where the first if will be met and then the elif will also be met. Because the reason why you would want to even bring an elif is if the first condition is not met. Do you understand? So you have if. Okay, you are introducing elif. That is when this one is not met. Okay, or maybe you can do a less than or greater than condition. But then once the first statement is, you can also have it like, okay, the first statement is met. It meets the second statement as well. So let's say you want to iterate between a number that is greater than 10 and it's an even number. Okay, you can have these nested ifs. Yeah, you can have these nested ifs statements where, okay, if the number is the number greater than 10, okay, true. Is the number an odd number? If it is true, then you can print number is greater than 10 and an odd number. Okay, but if even that one, you can have it in just one if statement, and then the if will be what the negative of what the first if statement. That is effective programming. Oh, somebody had their hand up. Is this Sasu? Yeah, yes, it's Sasu. Yes, go ahead.
Okay, with respect to what Iku was saying, I think I've met an instance where the system of authentication and authorization, when rules are specified. So a specific user might have the privilege of, say, an admin and say maybe a department admin.
Okay.
So sometimes you run your conditional statement that probably if the user that has logged in is an admin, this code should execute. Then you go to say else if. So sometimes you realize that the first condition is checking admin, the second is checking, say, unit admin, the third is checking section or department admin. And happening that the user that logs in has, say, two privileges. So
privileges, right?
Which privilege is going to run which code under? So something like that.
So that is where switches also comes in. All right. So with effective programming, you have to also make provision for those ones. So you and I cannot like sit here. Like we cannot just like, these are instances that happen. So you as a programmer would now say that, okay, so when these things is happening, or when I have situations like this, how do I mitigate that? Because we have multiple conditions being met. Okay, so you also write statements where, or you write your program in a way that they are going to cater for these things. You know, there are programs when there is even a way to handle errors, isn't it? I think you do error handling in Python. Okay, there is a way to handle errors. Usually on a normal circumstance, when you write your program without error handling, the program will just exit on a list error. So you have to write a way. You have to find a way to handle your errors. Okay, so when this thing happens now, okay, take this value and then save it here, and then maybe feedback the person that this is what is happening.
Yeah, sure.
You understand? Yeah, so Aoku, you said, so if age is greater than 16, print adult. Else, if age is greater than 65, print senior. Okay, and then else print child. Looking at this on a high level overview, I feel like there is a lot of things missing here. Okay, because you can't outright, because immediately the thing is greater than. So what if I enter? It's not even about 80. So what if I enter anything between, let's say, 60? Okay, so if I say 60, then it should print adult, isn't it? If I type, so you have to have a constraint. Okay, so the 16, you should have like something like maybe is between the ages of what? 16 and 60. That's like an effective conditional statement. Because if that is the case, if you have a program like this, it introduces ambiguity. the program will select any of them. So you as a programmer will have to actually sit down. So the programs that we all use, it's people who sit down to actually first think about it. All right. They first think about all the logical things that might happen, all the conditions that might happen, and then you integrate it into your program. Please, is that okay?
Yes, please.
Right. All right. Any more question? Since this Ima thing, since Mr. Auku, since Mr. Auku asks, you can feel free to like take us back, take us forward. Yes, Mr. Derek also answer.
Yes, and please, is there a difference between Git and then the GitHub?
Yes. So the difference is Git is the command line tool. GitHub is the repository, like the cloud storage for your repos. Okay. So this is GitHub. This is GitHub.
All right.
The graphical user interface where you can manage your codes and everything. And then Git is just the command line tool that allows you to enter Git commands. Where is my terminal? All right. So the command line tool. So it's a package, let's say a plugin. So it's a plugin like this. Yeah.
All right.
So you already have your terminal, but you install that plugin or that package to allow you to what? Write your Git codes. Okay. So if you open the website, that is GitHub, and then Git is the command line tool. Okay. Just like AWS. So the AWS management console is what the graphical user interface, the website where you interact with AWS services through the graphical user interface. And the AWS CLI is the command line tool or the plugin that allows you to what? Write AWS commands.
Oh, okay. All right. So it means it's possible you can use both together, right?
Oh, yes. So for this same thing that I did, I can decide not to even use the Git, the command line interface. Okay. I can just come here if I want to create a file. So let me go to repositories. The one that I just created. Okay, so if I want to create a file, as you can see, add a file. So I can decide to upload or create a new file. So the file contents, I am typing. I am typing, okay? And then who asked the question? Let me use your name.
I'm Derek Coulson.
Yeah. So sorry, this one I have to use small caps. So Derek Owusu. Let me pet name. Sorry for Deus. Yeah. So commit changes. All right, and then commit directly to the main branch, or I can create so commit changes. Nice. So as you can see, the file is here.
Oh, okay.
Yeah.
All right, thank you.
You're welcome, boss. Any more question? Yes, Emmanuel Mensah. I also have Emmanuel Mensah in my class. Emmanuel Mensah. He's your brother, eh? Or
no,
you know him?
I don't know him from anywhere.
Okay, go ahead.
All right, so you just mentioned about a branch. I just saw a branch. I just wanted to ask a quick question about that. In most cases, in my previous experience, I think we used to push it to our branch first, then we just merge it to the main later on. And I got lost somewhere in between because pushing, pull, they were just confusing. Later, you don't know where you're sending it to. So it's like you push everything to the branch, then later you push it to the main, right?
Okay, so it depends. All right, so I wanted us to just do some small touches, but it looks like All right. So the reason why you would want to have separate branches for, I mean, other purposes, all right, is for you to effectively manage your code. So in a typical work setting, you have your dev, you have your staging, you have production, isn't it? Environment, okay? Now, developers will have their own repo, okay, sorry, their own branch under the same repo, okay? So let me view all branches. So the main branch will be, let's say, the branch that leads to what your production environment. Okay, so you have a branch for the developers, you have a branch for staging. Now, so if you have a team of 10 developers, all of you will push your codes there. Now, for the main branch, you should have maybe somebody, your CTO, who will now review your code and then now merge it to what? The main branch. So once the code goes to the main branch, then it means that it is final. All right, that is what has been approved to be deployed. So always you pull from what? Anytime you would want to, I think most of the mistakes that developers do is that anytime you would want to work on a code, okay, the first thing you need to do is to do a git pull first. All right. When you do a git pull, you are able to pull the latest changes that anybody at all has done. Do you get it? And then you can work on it. Then you can pull it so that the merging will be what easier. If not, you see there will be this merge conflict and all those things. Okay. So the reason why you would want to create a separate branch and then push your codes is just because of that. So as we said, so that you don't get lost midway anywhere. So the main, nobody pushes to main. The main is only for
only when they are compiling.
So the main is mainly for like merging and then do the compiling and deploying. Good, you're welcome. Anybody else? Any more question? All right, so I've explained GitHub. I mean, it's just the repo that hosts your code, okay? So from here, anybody that doesn't have a GitHub account, please go and create some. Share your links. It's good. For my class, I always do pep talks. So if there's no question, we'll do pep talks. I'll do some small pep talk, then we'll move on. But we have some checkpoint questions that we have to answer. Since you are not asking questions, I think I can ask questions. The first question, what is one of the key purposes of programming? Why would you want to like write programs? To do what exactly? Mr. Emmanuel Mesa, go ahead.
Yeah, to automate stuff that I don't have to come back and just write hard code towards it.
I don't understand automate.
So
please come to my level.
So instead of me every morning to come to write a whole bunch of codes, I can just write maybe a bash script and just run it just directly, and it will just automatically start running it. And yeah,
I like that. You basically talk like the Emmanuel Mesa in my class, but just that his voice is deeper than yours. All right, Dennis.
Maybe I haven't eaten, that's why.
Okay, Dennis, go ahead.
So for me, I say the purpose of programming is to make the complex things sometimes we do as humans easier to do. So for instance, if it's something I have to think about, process with my brain and all that, I could just write a program which will just do it in a split second. I mean, that's what I'd say.
That's nice. I think Yakubu, I've heard your voice today. Harold, go ahead. Before I come to Yakubu, Haruna. Yes, Harold, go ahead.
Hello, everyone. I also say one of the reasons why you write code or program is to solve a
I'm struggling to hear you, Harold.
Hello, can you hear me now?
Yeah, I can hear you now.
Sure, that is great. So I was saying earlier that Hello.
Yeah, Harold, I lost you.
Okay, I was saying that we write
So,
problems and I
yeah.
use WhatsApp.
So this is what your is it your network or your voice is doing? Immediately you start, you know, it's like okay, you whet our appetite and then now the voice dips. What do you do? Anyway, you're free any.
Can you
Yeah.
hear me now?
Yes.
Okay, I was saying that we write programs to solve problems.
Okay. Yeah.
And I use
Yes.
WhatsApp as an example.
Nice.
Yes.
Yes. Okay, Ruben Junior Asante. I like food. Somebody should use food as an example. How to, order food or prepare food.
Yes, I also know the purpose of programming is to invite machines, for example, computers, to come help us in solving our complicated problems in this world. So like robots. Now, through programming, we're able to get robots to help us maximum production, help us to perform some specific tasks that human is beyond even human capabilities. So programming help us to also invite machines, computers to help us in solving problems. Thank you.
You're welcome. And this is an awesome submission. Okay. It looks like everybody wants to speak, but that's literally it, right? Programming is just we writing scripts to simplify repetitive tasks or to do repetitive tasks. So if you're a cloud engineer, you are an infrastructure engineer, your job is to take backups of systems instead of you to every morning come and type command. Okay, Emmanuel, we want to talk about food. Yes, talk about food.
All right, I believe you can hear me.
Yes, I can hear you.
You wanted an example in that area, right?
Yes, yes.
And one thing that comes to mind would be that, like in food preparation, we can use programming to make, let's say, delicious collaborative tools like what you just showed us today. That is the chocolate, right?
And his network
The network, okay.
has.
Also, I was saying that we use it to make like a delicious collaborative program, like the chocolate you demonstrated it to us
This man,
today.
you
Yes.
have vibes, man. You have vibes. Hey, the delicious all right, so that's basically it. Let's look at the next question. So which type of files are used to store programming source code? Which type of files are used to store programming source code? His vibes, man. Yes. Joseph, go ahead.
Yeah, so I would say test files with their respective extensions.
All right, Yakubu.
Yes, I also say text files.
Oh, say another thing. Okay, that's fine. All right. Yes, but mainly, you can have text files, you have scripts, anything that you can use to store your source code. Okay. What is an ID? Okay, first, let's look at the full meaning of an ID. I think beginning the class, when I opened VS Code, I said it. All right. What is an ID? Let me go down and mention some names. Nana Ajiman, Donfe, because these are people that Is it always like that? There was a class that I learned as for them. Some people, there are people who talk and there are people who don't talk. Is it the same thing here?
No.
No,
Okay.
here everyone talks.
Everybody
we
talks.
all talk.
Okay. Then let me pick from the bottom. Okay. Yes, so the Najiman, don't fair. I haven't heard your voice today. I've heard from the two women in tech. There's another woman in tech, Victoria. Your last name. Okay, Emmanuel Kuru, go ahead. Hey, sorry if I didn't mention your name well, right? I'm not good with names.
Oh, sir, that is that to Emmanuel Kuru.
Okay.
IDM stands for Integrated Development Environment,
Yeah.
which helps with writing.
It's
writing
okay. Don't
codes.
say all. Don't say all.
Okay,
Let's
sir.
Kuru of the cloud. Kuru of the cloud.
Yes, sir, boss.
Don't say all. Let's Miss Victoria also say some. Yes, Victoria, you can go ahead.
Okay, so ID is Integrated Development Environment, which helps for writing code.
Yes. Okay, so it helps us in writing code. And they said there is Jennifer. I am not seeing Jennifer here. Oh, Miss Jennifer. Is it Atimpo or Atimpo?
Either way, both of them is fine.
Okay, yes. So what does IDs help us do?
So it helps us to write code, to edit it, to there's a word for it when you have to check for errors. There's this
Debugger.
Yes, to debug your
Yeah, great. Yeah, that's great. Thank you for that. So what data type is a whole number? Okay, Kofi Adam, go ahead. You want to say something?
Yes, I wanted to just add more to the ID.
Yeah.
So ID also provides tools, libraries, and helps to manage the different aspects of the code. Yeah, so you have different text scripts, and you can use ID to coordinate all these texts and scripts to do a particular task.
Awesome. Awesome. Yes. So somebody said I should mention who? Is Penty Joseph? Yeah. Is it Penty or Penty Joseph?
It's Penty.
Penty. Okay.
Yes, but I've spoken several times.
Yes. I've seen Penty Joseph. That's fine. That's fine. Let
Penty are
me.
lying. Penty are lying.
Bruce Marty. Bruce Eli Marty or Marty. How's the name pronounced?
Yeah, Marty.
Marty, that's fine. So can you help us? What data type is a whole number?
The whole number is an integer.
Sacrosanct. My English is coming. Yeah, that is it. So integers are what? Whole numbers. Do you have a yes? So what is the purpose of functions in programming? Anybody? Okay, let me call our senior woman in tech, Beatrice Addison Winful. Beatrice, are you fancy?
Yes, please.
Oh, I see. Functions, yeah, baby.
For your functions here, code snippets are. Hey, let me speak English. Sorry.
Oh, which is flow. I like the fountain.
I don't think it's everyone who understands fancy. So
Who told you?
Yeah, please speak English.
Yes. I'm on their way. I don't understand fancy.
They are lying. Please speak your English.
Fancy base for.
Mama, am I confused?
Oh, man, you're confused. Speak fancy.
Oh, can we allow her to talk?
Okay, so functions are code snippets that help us to avoid repetitive tasks. So I don't know how else to describe it.
Yes, that's it. And don't let me stress you. So yes, they are code snippets. So you see the if statements like this, right? You can decide to put it into a function, all right? So that anytime you would want to perform that function, you would just call it instead of retyping the whole thing. Okay, so in your code, let's say you have a series of conditional statement that you want it to go through. So all you need to do is that in every portion or section of your code that you want to perform the same steps of what if conditions, all you need to do is to what? Just call the function and then pass an argument to it. Okay. So this one there, I open Google right now. This don't call me. Everybody should mention one version control tool. I know Git, so don't say Git. I know GitHub, so don't say GitHub. So let's go the rest. Yes, Perez, yeah, boy.
AWS code commits.
C'est bon. Mr. Richard Amoa.
Git bucket.
Yes, Bit bucket. Mr. Emmanuel Aoku.
And one of okay, GitLab.
Who again? Minty, Mr. Emmanuel Jennings. And there's even the one that we saw. There's one that you haven't mentioned though. Okay, Mr. Jericho Usu, go ahead.
Is that a Mercurial, right?
Yes, Mercurial, yeah.
All right.
And then Mr. Emmanuel Kuru.
The GNU Bazaar.
C'est bon. All right. So that will be it. Our time is exhausted. I like to keep my pep talks off recordings. Please, can we stop the recording?